Actually, I did want to respond to some of the questions that we've had in the live stream chat. Some people were asking about testing. I just want to make sure that folks are aware before I get into my session that there is just about to bring a screen over, an easy way to add test projects to Aspire. So if I search for Aspire in the templates here, we can use the starter application template and just go through, and we can actually click create test project. And if I do that, we'll have a test project. In this case, we'll be using NUnit. With .NET Aspire 8.1, we've added support for NUnit and MS Test as well. And so what that will do is it will add a test project here. And if we look at that, you can see that we have a test case here which uses the distributed application testing builder API. I just want to make sure people are aware that that's there and get started. And you can also add the test projects separately. So if I go and add a new project, so this is if you've kind of already started building your application, there is a test project. And with .NET Aspire 8.1 installed, you'll see MS Test and NUnit project templates here as well. Okay, so with that out of the road, I'll get on with my actual session, which is the .NET Aspire Extensibility. So I'm Mitch. I am a member of the .NET Aspire team, and I spent a lot of time working on the application model at Aspire. So what that means is, when you create a new Aspire project and you go build a .add something, I'm one of the people on the team that's helping build out those APIs. So what I want to do here is talk about how you can extend the API surface within .NET Aspire yourself. And the way I'm going to do that is sort of go through some of the .NET Aspire code itself and show you how it's all hooked up. And then you can use that knowledge to go and build your own extensions. And of course, if you're building extensions to support, say, common open source container workloads and the kind of stuff, we would encourage you to consider, sharing those libraries on NuGet so other people can take advantage of them. And in some cases, even contribute them back to the main .NET Aspire repo. In fact, a huge number of the extensions for .NET Aspire actually have come from the community, both in the 8.0 release and the 8.1 release. So it's been really exciting to see that. Okay, so this is some sample code from this is from what we call our test shop. This is actually an app host which is within the main Aspire repo, and we use this for testing out a bunch of different scenarios with Aspire. And so you can see here that we are creating our distributed application. We're adding Postgres, we're adding Redis. So most people who have used Aspire will be fairly familiar with this code. What I want to do is sort of peel back this layer a little bit and just sort of see what happens in your application when it launches, and what are some of the base building blocks that we work with Aspire. So with that, I want to sort of walk through a little bit of a diagram here. In fact, I'm not sure why. There we go. Sorry about that. I want to talk through some of the layers in the application. So with an Aspire application, when you launch it, you're generally launching it from an IDE. That might be Visual Studio, it might be VS Code, Writer, or you might even be just launching it from the command line. So there's always this thing that launches .NET Aspire. And what that launches is our app host executable. Now, the app host executable uses the application model APIs within .NET Aspire to describe the application in detail. So we want a container and we want a project and we want a reference between the project and the container. And that's kind of what the application model is for. And so we have this launch experience that happens here. The app host executable, so this is your code in program CS, is manipulating the application model. And then the application model, when you run the application, starts up this thing in the background called DCP, or the developer control plane. And the job of the app model is to translate what you've put in your program CS into a series of resources that DCP understands. And so DCP, what it does is take care of things like launching the dashboard. So we tell DCP to launch the dashboard, and the dashboard itself controls what is rendered on the screen by talking back to a resource server which is running on the app host. We then tell DCP to launch any local processes. So that might be, well, we spin up reverse proxies for any sort of exposed endpoints that you've got. And then we launch the processes that those reverse proxies talk to. So we launch those, and there'll be multiple of those. And then we also launch any containers. And obviously, .NET Aspire supports a bunch of different container runtimes. So we support Docker, but we also support Podman. But conceptually, they work the same way. And so we launch the container run. So we talk to the container runtime, and the container runtime launches the containers. And both the local processes and the containers have configuration injected into them, which allow them to send telemetry back to the dashboard. So those containers are sending OTLP telemetry. We've already seen a few sessions this morning around OTLP, and so the dashboard is kind of like the OTLP endpoint. Also, console logs and all those kind of things go back into the developer control plane, and we expose them to the dashboard via the app host. So that's like the 30,000 foot view as to how the system hangs together. Now, when we talk about extensions, I know that Eric has already done a session today where he talked about Aspire components. This session, I'm going to focus more on the extensibility of the actual app host itself. So the things like add Postgres, add Redis, those kind of things. But they obviously have sort of partner components that run within your actual service code. So let's look at that code again, and this time let's look at this with the lens of what is an extension within this app model. And so if we look through the code here, we've got a lot of common elements which are just part of the core model within .NET Aspire. So we're creating the builder, but things like add Postgres with data volume, with pgadmin, add database, they are all extensions within .NET Aspire, which we ship out of the box, but they use the extensibility model. And so if you think about all the things that an extension that you want to write needs to do, well, chances are we've added support with it within the .NET Aspire application model, because we have every single extension in its own little package to kind of enforce some core principles. Okay, so let's jump in and look at some of those primitives within .NET Aspire. So one of the key takeaways from this session is .NET Aspire itself is built upon a relatively small number of key concepts or building blocks. And so we talk about resources and we talk about annotations, which I'll show in a second, which you're not immediately exposed to when you use Aspire for the first time. And all of those together control how the application launches. So let's jump into it. Away from my pen. Okay, so let's talk about builders and resources and annotations. So I'll jump into Visual Studio here. So this is that same code listing, and we're inside Visual Studio, and I've actually got the Aspire code base opened at the moment. And what I'm going to do is I'm going to launch this application, and I'm going to set a breakpoint, and we're going to drill into some of the underlying data structures just to sort of get a sense of how things like annotations are used to control the launching of applications. So we have our builder API that returns an iDistribute application builder. And then on that, we have things like add Postgres, which is an extension method which injects another resource. We're going to drill into that in a second, but I'm just going to launch the application first. I'm just going to look at what an application model, what the data structures look like. So inside the locals window here, and I apologize for the size, you can see here that we've got some variables which are holding our resources. And if I drill in on those and I look at the resources, you can see that there is a series of annotations which are inside the resource. And those annotations describe things like what container image that we're going to use, what, if any, data mounts that we've got on the container, as well as a few other things like network configuration endpoints, like an endpoint annotation, and even some callbacks to configure the command line arguments on the application. And so when we continue running this application, those annotations will be processed by .NET Aspire and turned into calls to DCP to control how a container starts or how a process starts. Okay, so I'll just stop debugging that now. Okay, so when we look at building a hosting extension, we're really talking about providing some extension methods for this builder API. And so I'm going to look at, just as an example, the add Redis extension method, and we're just going to drill down on what's inside that. So I'm going to go to definition. So this is the add Redis extension method, and you can see here that it extends the distributed application builder. It's got a few arguments. So one of the things that you always have to provide for a resource is a name, but then you might have some optional arguments which might be super common, like specifying a port. Sometimes there's like parameters that you can pass in and that kind of stuff as well. But this resource is relatively simple. We have a Redis resource, and if I look at this Redis resource, you can see that it derives from the container resource. It also has this interface here, which is, it's a resource with connection string. So .NET Aspire has a bunch of iResource with X interfaces that you can implement. And often there's no methods, they're just a marker interface. And that gives it the ability to participate in the builder API model that we've got here. So let me go back into the add Redis method here. So we're creating the resources, we're providing the name, and then we're taking the result of the add Redis resource, which is an iResource builder around Redis resource, and we're decorating it with endpoints and other metadata. So here we're saying we want an endpoint that points to the default Redis port that is used within the container image that we're using. We tell it what container image we're using and what registry we want to use. And that's kind of it for building an extension. All right. So you can see how there's very few core building blocks under the covers here for creating a resource. Now, when we run these extension methods, sometimes they need to participate in the life cycle of the application. So if you look at the APIs here, we have things like with pgadmin and in this case with Redis Commander. So if I run this application and launch it, and we just drill in and have a look at the dashboard, just want to point a few things out. Okay, we're launching. Oh, it's looking at the wrong window. Okay, so we can see here that we've got the dashboard. So it's now gone and started a bunch of containers and processes for our test application. And we can see that we've got our basket cache. This is our Redis instance. But you can see we've also got our Redis Commander instance. And if I click on that, I can drill in and I can see that I've got my basket case it's just as connected to, and I could add Redis keys or inspect the keys, which my application's already created. So if I jump over to the front end of the application, and add something to the shopping cart and check it out, we should be able to go back to Redis Commander and refresh. Oops, I should have checked that out. Go back and refresh. We can see that I've got the shopping cart data there. So this is all standard sort of Aspire functionality. We've got those with Redis Commander APIs and with pgadmin. But what I wanted to talk about with those is how we make those work so that if I had multiple Redis caches, that we could have a single Redis Commander instance, which actually could look at all of those. And we do that by using a feature called distributed application lifecycle hooks. So if I drill into the with Redis Commander method here and go to the definition, you can see here that every single time we call with Redis Commander on a Redis resource, we look at the application model. And so from every single builder, you can get to the root distributed application builder. And we're searching for all the Redis resources or the Redis Commander resources. And if we've got one, then we don't add another one. We just do some configuration if we need to. But if we don't have a Redis Commander resource added, we do a few things. First of all, we add a lifecycle hook, which is this thing here. We're going to look at that in a second. But we then go and add another resource, which is the Redis Commander resource. And if we look at this, you'll see that this is just another container resource. All right, so once again, we're building on these basic building blocks that we have in Aspire today. And so what's happening is that we're setting up this config writer hook so that when we launch the entire application, Redis Commander can be given all of the configuration information it requires to inject connection information to the Redis instances that are running in the app. And so I'm going to go in here and I'm going to go to the definition, and this is the distributed application lifecycle hook mechanism that we have within Aspire. And so you can build these yourself and register them with the DI registry inside Aspire. And they have, if I look at this this definition, we can see that the distributed application lifecycle interface has a bunch of methods that you can override. It's got default implementations, so you don't have to implement all of them. But we have basically these callback methods which can run before the application starts or after endpoints are allocated. So the way that the lifecycle works within Aspire is that when you launch the Aspire application, we get DCP to first create all of the reverse proxies. So we kind of know up front we know up front that all the endpoints, so port mappings, IP addresses, that kind of stuff for the services. So we spin up proxies for those. And then because we know those, we can use that configuration to go and populate configuration between different machines. Sorry, between different containers and processes. So this Redis Commander lifecycle hook is actually an example of that. So when all of the endpoints are allocated, we then get invoked, and we look at the application model to see if Redis Commander has been configured, as it should be. And then we then look for all the Redis resources, and for every Redis resource, we go through and we extract the endpoint information. So it's the host name and the port, and we inject that into an environment variable, which is then passed into the Redis Commander container that we start up. And so this is an example of that sort of ability to expand the programming model within .NET Aspire and add on to existing resources. In fact, there's been a few contributions to Aspire itself where people have come along and said, okay, well, we can see you've got this resource, but we would like to have this sort of like management UI that you can bolt onto the side of it. And people have contributed code using exactly this kind of mechanism. Okay, so let's let me jump back to the presentation. Just quickly check to see if there's any questions as we go. The types that, so from Simon here, we've got the types that iResource Builder works with to define the Extensibility API. Are they definable by extension, or are they common between all extensions? Yeah, so we have some base types within .NET Aspire. So we have like executable resource, container resource, project resource. They are like the base level, but ultimately there's just like an iResource interface. You can define your own resources from scratch. And the Builder API is designed to work with anything that implements iResource. But then we have some extra interfaces that you can add to your APIs to light up different extension methods. So as a concrete example, let's go and look at container resource. So if we go back to Program CS here, and I'll look at Redis, and I'm going to drill into it. You can see that the Redis resource derives from container resource, and it also implements the iResource with connection strings. So if a resource implements this interface, this means to Aspire that this resource can actually provide a singular connection string value. And so it's useful for things like Redis, SQL Server, Cosmos, all those kind of things. But if I drill into the container resource itself, you can see that container resource just derives from resource, but it also implements iResource with environment. So that means that a container resource can actually have the with environment extension method applied to it. And so if I go to Program CS, you'll notice that because it's a container resource, there's a whole bunch of extension methods that are available here. In fact, one of the things that we've just added in .NET Aspire 8.1 is the ability to override the Docker file that's used for a particular resource, so you can customize it. But yeah, we've got things like with environment here. So even though this is a pre-existing resource, like a typed resource, a Redis resource, I can still treat it like a container and extend it and modify it. So the application model in .NET Aspire is quite malleable, and that means it's actually quite easy to extend as well. So you can either just extend it within your specific project by having a few extension methods, or you could build your own NuGet package and share that extension with the world. Or and if you think that it's applicable to every .NET Aspire application, you should file an issue in the Aspire repo, and we can have a chat about adding that API surface to the core product. We've had lots of those contributions. Hopefully that answers your question, Simon. Okay.
Thank you.
So how are we going with time? So we're pretty much at time. That's most of what I wanted to cover. So yeah.
Mitch, thank you so much for your presentation. But I know, don't worry, we are very on time. But it would be unfair to not ask that question, but you have just one word. What do you represent .NET Aspire Dev Day to you? One word only, just to get it quick. Not to be unfair with you.
I am excited to see how many people are interested in Aspire. Like it's amazing.
Okay, thank you so much, Mitch, for this incredible presentation. And you learned so much today in Aspire Dev Day, man.